Welcome to SolidCAM Professor in a video series to help you get started with iMachining. In this session, we will make adjustments to our default CAM settings and create a new milling CAM part. Then, we'll cover the basics of creating a new iMachining operation, which include making a new machine database, selecting a material database, and completing our workflow in the operation dialog. Finally, we will simulate the morphing spiral toolpath generated by our revolutionary iMachining technology. First, we'll need to open our example SolidWorks part. Please note that this part file does not come with the installation of SolidCAM. The example file will be included with this video tutorial. The part file can either be opened directly from our Getting Started interactive guide or by first downloading it here from our website. I saved my downloaded part file to a SolidCAM training folder that I've created on my C drive. I recommend you do the same. Let's open SolidWorks. Go to File in the SolidWorks menu and select Open. When the dialog opens, let's look in the C drive under Computer. Select the SolidCAM training folder from the list, and then choose the SC Aerospace Part 1.SLD PRT and open it. Before we begin, let's quickly discuss our automatic CAM part definition settings. In the SolidWorks menu, click on SolidCAM and select SolidCAM Settings. Under Automatic CAM Part Definition in the list, note there are four important sections: Definition of CNC Controller, Definition of Coordinate System, Definition of Stock, and Definition of Target. By default, these settings are enabled and can be especially helpful for a 30-day trial test drive user. Keeping them enabled automates the CAM part definition process so you can start immediately adding operations. For the purpose of this example, assure that the automatic CAM part definition settings are disabled by unchecking the appropriate boxes. If you are a customer renewing your subscription, please verify that your automatic CAM part definition settings are disabled before you continue. While in our SolidCAM settings, go to CAM part in the list. Note that we now have two modes for saving a new CAM part, internal and external. External is typical for CAM parts saved prior to 2013 and uses the .prt or compress.prz file extensions. External handles the saving of a CAM project by building and working in an assembly. A copy of the original SolidWorks model is generated, and all CAM data is created and stored outside the original .sld PRT file. External is beneficial for CAM users without access to an engineering group's original SolidWorks model. Although the CAM data is saved separately, it remains associative to the original .sld PRT file. Internal, on the other hand, manages our CAM project with a single SolidWorks model file, using a part-only mode. The CAM part is created, and all CAM data is stored inside the original .sld PRT file. Internal is especially beneficial for users who build both the CAD and CAM, bringing SolidCAM's integration to a whole new level. For the purpose of these iMachining tutorial videos and moving forward with our interactive guide, let's set the radio button to internal. By default, the internal mode will be selected upon creating any new CAM parts. Let's also change the default CNC controller. Go to Default CNC Controller in the list. Under the Milling CNC Controller section, we can browse the database by selecting the drop-down menu. Let's select the G-milling post for a 3-axis Haas SS as our default CNC controller. Click OK to close the SolidCAM settings dialog. Now, here we have this part ready to go into SolidCAM for programming. First, we'll create a new CAM part using the SolidCAM drop-down menu. Go to SolidCAM New and select Milling. We'll be prompted to save this new milling part. Internal is selected to create CAM part by default, and we'll click OK to accept our CAM part name SC Aerospace Part 1_milling. In the milling part data dialog on the left, we will see that our default CNC controller selection, G-milling Haas SS 3X, is listed under CNC machine. Next, we will need to define the coordinate system, also known as the Part 0, for this job. Click on Define under the Coordinate System section to display the CoordSys Manager. Note there was already a coordinate system created using SolidWorks, as you can see here in the SolidWorks graphics area. To use that, first click Select Coordinate System from the Define CoordSys options list on the left. Then, Select the already created coordinate system from the list below, and then click OK to accept. The coordinate system axes are represented graphically by color, just as they are in the lower left-hand corner of the SolidWorks graphics area. In our next window, we can control our default machining levels. For this example, let's click OK to accept the default Z levels. In our CoordSys Manager on the left, we see that our coordinate system has been created. Mach 1, Position 1. Again, let's click OK to accept and exit the CoordSys Manager. Next, we will define the stock material and target geometry for this job. First, we'll click the Stock button in the Milling Part Data dialog. Under Define By, we will select 3D Model since there is already a solid body created representing the stock material. Pick on the stock body in the SolidWorks graphics area, and then click OK to accept the selection. Defining the target geometry follows some similar actions. Click the Target button under the Stock and Target Model section. Pick on the target model in the SolidWorks graphics area, and then click OK to accept the selection. Now, we can click OK to complete the CAM part definition. To make a new iMachining operation, right-click on the Operations folder in the SolidCAM Manager, highlight Add Milling Operation, and select 2D iMachining. When the first iMachining operation is added to our CAM part, we'll need to define the machine and work material parameters for the iMachining database. First, let's define the machine database. As you can see listed here, a Haas SS is included with the installation of SolidCAM for other walkthrough exercises. For this exercise, let's create a new machine database. Under the machine list, click the New icon. A dialog will prompt us to enter a name for the new machine database. Let's name it Haas SS New. Clicking Save verifies the database has been successfully created. Let's click OK to add the machine file to the list. There are 3 required values needed in the machine database. They are represented here by the yellow fields. For spindle speed max, enter 12,000 RPM in the input field text box. Then, enter 21,158 millimeters per minute for feed rate max, G1. Lastly, let's enter a spindle power max value of 20 kilowatts. Clicking Next will bring us to selecting a material database. These are provided. All we need to do is select the desired material. If there is no database matching the material we are cutting, selecting a similar material will be acceptable. For this example, let's choose aluminum with a 100 Brinell hardness number and a hardness Rockwell of 60 on the B scale. These database selections will affect the cutting conditions generated by the Technology Wizard. Now that our machine and material databases are defined, let's click Finish to display the iMachining operation dialog. For this example, we will use the default iRough machining strategy for our technology. Let's click the New button to define our machining geometry. When defining geometry in iMachining, keep in mind that the geometry is defined as a pocket that can be open, closed, and/or semi-closed. We will discuss many different geometry types suitable for iMachining in our latter videos. In this session, we will select a simple closed pocket. Pick on the lower contour of this closed pocket in the SolidWorks graphics area, as shown here. Select Auto Constant Z from the Geometry Edit dialog on the left, and then click Yes to accept the selection. This action will close the chain by automatically selecting all connecting entities on the same Z level. Now, we can click OK to return to the iMachining operation dialog. Moving down the tree, next we need to create a new tool. Clicking Select will bring up the tool table. Click the Add Milling Tool icon and choose End Mill from the Milling Tools list. Under the Topology tab, let's define the physical dimensions of the tool. I will enter a value of 12 millimeters for the diameter. I'll keep the default remaining tool parameters, but change the number of flutes to 5. Now that we're satisfied with our tool definition, click Select to close the tool table. Next on the tree, we will define our milling levels. First, click on Upper Level. In the SolidWorks graphics area, pick the top face of the stock material. Then, click OK to accept the selection. Next, select the Pocket Depth button and pick on the lower contour of the pocket, as shown here. Then, click OK to accept the selection. Now, let's switch to the Technology Wizard branch. This wizard automatically calculates the cutting conditions for the iMachining technology, considering the machine, work material, tool data, and milling levels defined for the operation. We will discuss using the wizard in more detail in our third video session. Now we can click Save and Calculate to add this iMachining operation to the CAM tree and calculate the toolpath. After the calculation, let's click Simulate to view our iMachining toolpath. The simulation control panel is displayed, and we'll use our default simulation mode, HostCAD, to view the wireframe toolpath on the 3D model. Press the play button to run the simulation. You can use the simulation speed slider to play the simulation at your desired speed. After the simulation ends, let's switch to the Solid Verify mode by clicking on the appropriate tab. Now we can press play to view the cutting tool moving through the solid stock material. Let's now exit the simulation by pressing the eject button. This will take us back to the iMachining operation dialog, where we can prepare for our next video of the series. And this concludes our first session in the SolidCAM Professor video series to help you get started with iMachining, where we've created a new milling cam part and iMachining operation. Thanks for watching. Please join us for our next session, defining a tool and its parameters related to iMachining.